Okay. Can everybody hear me? Can you guys hear me in the back? Okay, great. Welcome. This talk is mobile attacks, what will the future bring? I'm going to go through a couple. There's a bit of an agenda so you can see where we're going through this presentation. I'm going to do a little bit of an introduction, explain who I am and sort of where I come from. Then we'll talk about mobile device landscapes, some attack scenarios, some of the historic attack scenarios. I have some demos, and so I actually have 3 live demos, and we sort of cross my fingers, cross every finger I have, to make sure that hopefully everything runs correctly. There's some self-contained stuff, and there's some things that are using things on the outside as well. So hopefully everything runs well. We'll see. And then talk about some of the future stuff, some future-looking things that I've been thinking about, and sort of trying to predict. Obviously, predicting things isn't always the best thing to do at a security conference because we all usually fail at that. But trying to come up with ideas around where these attacks are going to. And then if we have some time, we'll open it up from some questions. So brief introduction. So a little bit about me. So I've been doing InfoSec since the 90s. Started out my career doing penetration testing back in the 90s. Got into some incident response and forensics work. And then also, I also formed the Sputter Labs team in 2005. So I have a bunch of Sputter Labs members sitting right there in the audience here. But I formed that in 2005. I've also given talks at places like DEF CON and Black Hat, and have given briefings for the Department of Homeland Security, US CERT, Secret Service, all sorts of other places. The areas of research that I'm really interested in, so obviously in my day job, I run the Global Sputter Labs team at Trustwave, but in my sort of spare time, I guess, I'm interested in data breaches. We do a lot of forensic investigations, so I like to read those reports, understand what's going on in those scenarios. Also malware, I'm very interested in that, and then mobile computing. A mobile fan, and so this is where this talk really is very interesting to me. I'm also the primary author of the Trustwave Global Security Report. We actually have, it's something it's put out every single year, put out in February typically. We do have some copies at our booth that's literally right behind that wall. And then of course you can find me on Twitter, C75 on Twitter, a lot of beer tweets, and occasionally some InfoSec tweets get mixed in there as well. A little bit about Sputter Labs, not going to spend really much time on here. This is the one slide sort of commercial about where I'm from. This is really what we're all about. Within that blue box, response and investigations, analysis and testing, and research and development. That's all that my team does within Trustwave. And then we take in threats, we analyze them, we sometimes discover them ourselves, and then also that results in protections for our customers, products, our MSS, and then also our partners that we exchange information with on a regular basis. So let's jump into the meat of the presentation. So what I want to do is sort of set the stage from how I see mobile devices and sort of walking through sort of from my perspective. We talk about the mobile device landscape, and the first thing that comes to mind, I guess in my mind, is usage. How are people? What are people doing with these devices, or what's going on with them? So the first thing we have there is really there are over 500 million devices on 3G, 4G, LTE networks today. In fact, just on the stage, there's a 3G MiFi here. There's a 3G Samsung phone. I also have my iPhone in my pocket, and I have my iPad in my bag. So I have 4 devices on stage. And many of you probably have multiple in your possession as well. By 2020, it estimates there's going to be about 10 billion devices. That sort of exceeds the number of people on the planet probably by then. But like I said, I have 4 devices just here, and you probably have many of them in your pockets as well. The other thing from a usage perspective is that 60% of users carry their devices at all times. Now, if you equate that to people in this room, it probably is near 100%. That you're not really turning off your device. You're not putting your device in the car and then going in at night and going to bed. You're taking that device with you. You're putting it on the nightstand when you wake up in the morning. You're checking your email. You're taking it to breakfast with you. You're traveling with it. So it's with you at all times. So that makes things very, very different than a PC, right? So if you think about PCs from 10 years ago, the mobile devices you have today are actually more powerful than those devices. They have always-on network connectivity. They have GPS awareness, right? So you can see where that device is located anywhere on the planet. And you have a lot more personal data on those devices today. And so if you think of that from an attacker's point of view, that's a pretty juicy target. If I was to target, pick somebody in the audience and target their phone or their device and get access to that, there's a lot of things I can do, right? And so we'll talk a little bit more about that. Also, interaction. When you think of people using their devices, they're accessing highly sensitive information. Now, how many people here have checked their bank account from their mobile device before? Yeah, it looks like half the room. Raise their hand. So you typically will trust your mobile device over something like the hotel here, and I'm staying at the Holiday Inn that's down the street here. There's a kiosk in the lobby of that Holiday Inn. How many people here would check their email on that kiosk? No, good. No one raised their hand, right? So you wouldn't do, how many people would, you wouldn't even log into anything, right? So you see people using it, and you sort of feel bad for them. You're like, guy's using the kiosk, he's going to be in some trouble in a couple hours. And so basically, the users would trust their smartphones over a kiosk. And the other question is, do you really rarely ever question the integrity of your smartphone or your mobile device? How many people here have ever themselves or have had friends say, hey, my phone just got a virus? Is anybody in the room? No, but yet we know there's tons of mobile malware out there. You hear about it all the time. We as an organization find mobile malware through our research teams, and so that's really odd, right? So how many people here have heard people say, I have a virus on my computer, right? Look, everybody raises their hand. You hear about it all the time. My dad calls me up like every day and says, I have a virus. What is this? He's asking me these questions, and so that happens all the time. And then the other thing from an interaction perspective is that you have limited desktop real estate. So I pull out my iPhone here, and of course it has a 4-inch screen on it, but that's it. And when I'm using an app, it's filled the entire screen. And so it's very different than when you're sitting in front of your 30-inch monitor or your 30-inch screen, then you have multiple windows going on, you have multiple desktops going on. If things are sort of running awry and you have notifications and a lot more activity going on, you notice it. You have antivirus running, that pops up a pop-up. Maybe you have a little snitch running and it's telling you something's trying to send traffic off of your computer, and you can notice it. But on a mobile device, you don't, because you don't have that. And then also when there's messages that are sent to the end user, they're often cryptic or misleading. We were doing some SSL testing back last year, and every single time we would try to man in the middle basically some apps on iPhone devices or on iOS devices, we would get pop-ups that would say the internet connection's not available. Well, that's completely different than what we were doing. We were trying to use malformed certificates to try to cause it to, so we can intercept traffic, and the error message to the user was your internet connection's not available. So that's odd, right? So obviously they couldn't connect to the internet, but there was something else going on, no security warning, and it was misleading. The other area, when we talk about security, dive a little deeper, is that there's no standard UI for mobile apps. So if you have, if you're on your online banking account, you're checking your balance, and then you go and you try to buy something on a store through 2 different apps, there may be some security things going on within those apps, but they typically don't tell you about it, and you typically, even if they did, it looks different in one app versus the other. And so, similar to like when you're using your browser, every single e-commerce site that you go and you visit and you're trying to put your credit card information in, there's the green bar or the lock that's always standard, and users have been trained to understand that. At least we hope they have. And so how does an end user know when they're using a mobile app that their data is actually being encrypted? You go and you check your bank account, you're pulling down all your details. How do you know that's say an SSL connection? You don't as an end user. And then we sort of dig a little deeper from a software development standpoint. The end users themselves, or sorry, the software developers, there's zero functionality difference if I'm a developer and someone hired me to build an online banking app for a phone, and I go and build it and enter username and password, I build the backend server as well, and I do everything over HTTP. I show it to the customer and say, here, look, it works. You can log in, you can do all these things, and you hand it to them, and they're maybe not security aware, and they go and they implement it, they send it out to their customers. The functionality is exactly the same if their customers are sending their traffic over the network in the clear than if they were sending it over HTTPS. And so even from many software developers, there's been cases, you probably all know about them, where apps have leaked data because the developer is sending that data over HTTP versus HTTPS. And then the other issue from a security standpoint is when there are problems with a mobile device, you end up with, in many cases, if those applications are relying on a library or something that's part of that OS, those problems then cascade to all the devices, all the applications on that device. And we'll talk a little bit more about that as well. But when we think about mobile commerce, people creating these applications that have to send sensitive data, what happens to their community? What happens to their population, their end user population? Do they then have to go send an alert out that say you're running an old version of iOS and it has a problem, you need to upgrade? Or do they just sort of let it go and hope that someone doesn't get owned because of that problem? So now let's talk about some of the mobile attack scenarios. And so what I have here is basically, I guess in my mind, the mobile market really breaks down into two flavors, right? You have iOS and you have Android. Obviously, there's BlackBerry. How many people here have a BlackBerry? Okay. How many people here have a BlackBerry because their employer bought it for them? Okay. So basically, yeah. So I mean, and then the other thing, how many people have a Windows mobile phone? No one. Oh, there's one in the back. So he either works for Microsoft or he's from Finland, right? So you have the Nokia guys. So yeah. So I mean, so basically the market's iOS and Android, 40%, 50%. But the difference is here, right? Obviously, iOS developed by Apple only runs on Apple hardware. And then you have Android, and that runs on anybody's hardware, basically. You go into an AT&T store and you say, I want an Apple phone, and they go, here's these 2 models or 3 models we have. You say you want an Android phone, they go, here's these 87 models you can pick from, and just sort of pray that you get software updates 6 months from now for many of those models. So let's talk about some of the attacks. And so this section here, I'm going to sort of walk through some of the various attack scenarios. And then we'll show you some demos, some different types of scenarios, some demos and things. But really, this is me sort of putting on, if I'm putting on my hacker hat, and I'm saying, well, if I'm going to target the iOS community, how am I going to do it, right? One of the first things that comes to mind is jailbreak vulnerabilities. I'm sure everybody in this room knows what a jailbreak is, but I sort of see it as a sort of virtual arm race between the jailbreak community and Apple, right? So Apple comes out with a new version. They came out with iOS 6, and everybody's trying to find a jailbreak, for iOS 6. And that's for that community, that's great because people want to go and they want to jailbreak their device. They want to be able to install apps that Apple doesn't want them to. It's not available in the App Store. They want to make modifications. They want to make tweaks. They want to be a hobbyist with their iPhone. And so that's in sort of this the non-security sense, that makes perfect sense, right? Someone may want to do that. You put on the security hat, and as an attacker, I may be able to take that same jailbreak vulnerability and weaponize it. And launch it and use it as a way to get administrative access on someone's device and be able to install my malware or do things to someone's device. So obviously, a couple days after each release comes out, or even before a release comes out, when there's just sort of the gold master that's there, people find jailbreaks. And so basically, a jailbreak is possible with all iOS versions. Now there's tethered versus untethered, but we actually took this back in a couple of years ago at TorCon 12. And actually weaponized it, and we demonstrated it to the audience there. We took the jailbreakme.com basically exploits down, took those down, reversed them, created our own toolkit that basically we were able to show that you visit this website, we can now install a piece of malware on your device and get remote access to it. And so those things are feasible from an attack perspective. Another way against iOS devices is something called SSL Men in the middle. Now, myself and a colleague named Paul Kerr were doing research last summer, or actually last spring, and basically our whole premise of the research was to try to find if there was any apps that have SSL flaws. And it turned out when we were doing our testing, we ran across, we were doing iOS testing, and we were feeding it different types of malformed SSL certificates, and one of them worked. We were like, wait a minute, this is sort of odd. We're actually men in the middle in this iOS device via this malformed SSL certificate, and we're able to intercept traffic. And so we started digging deeper. We tested it again. We asked some other people in Spider Labs to sort of validate this for us so that we didn't think we were crazy before we contacted Apple. We ended up contacting Apple, and they fixed it in 10 days. They went and fixed the problem, pushed out an update to 160 million end users out there. So the interesting thing there is, also Apple didn't make a lot of noise about it, right? You didn't see a press release, you didn't really hear much about this problem when it happened, but it turned out that it was basically the same flaw that I think it was in 2002 that Moxie discovered in IE. So 2002, basic constraints vulnerability in IE using SSL, and now it's 2011. And that flaw exists on an iOS device. And so when we notified Apple, obviously if anybody's reported vulnerabilities to Apple, it's very cold, right? You email and then you get like a robot that emails you back, and then you don't hear anything until you follow their phone tree and actually talk to the folks that sort of were signing that email. And is Steve here, Steve Osepik? He was the guy who got us in and got us talking to Apple. But yeah, so basically what that meant is that any device running 4.3.5 or earlier is vulnerable to this attack. So I guess this sort of asks this question: how many people here are running iOS 4.3.5 or earlier? Is there anybody? No. So one thing, so that's the same guy with the Windows mobile phone. Let's see. So the one thing interesting here is we actually demonstrated this at DEF CON last year And we ran a test. We had an SSL test site, and we thought, well, this patch had been out for about a week and a half or 2 weeks, and we thought everybody in the room would be up to date by now. But then you forget about the jailbreakers, right? The jailbreakers don't want to update their devices. And so we actually ran this test and had people visit a website and said, if you see the Sputter Labs logo on your screen, raise your hand. And we sort of brought it up in sort of a reverse way, saying, hey, we're going to test things. And then we told them about the problem. We had, I don't know, like 85, 90 people raise their hand in the audience, and they're all vulnerable to this attack, which we thought was interesting. In fact, there was a couple people who actually didn't have iOS devices that were sort of these really cheap sort of throwaway phones that actually were vulnerable to that as well. And we've been trying to go down the disclosure path with those vendors, and it's a little bit difficult to get their attention. So basically, think about this. So with this problem, what were mobile banking and e-commerce organizations doing about this problem? We actually had some mobile banking customers of ours call us and say, you guys told us about this problem. What do we do? And so you put on the security hat and you say, well, you got to cut off all the customers who are using 4.3.5 or earlier. And they said, whoa, that makes sense. Let's see what the impact is. And they went and they looked, and the impact would have been 98% of their customers at that point. And so they were like, that's not going to work. And so they basically went and did some communication to their customers and tried to educate. But I think even still to this day, they probably have a lot of customers that are still vulnerable to this. They're just rolling the dice from a risk perspective. Now let's talk a little bit about some Android attacks, some things that are going on in the Android world. Obviously, if I'm a attacker and I want to get some malware or get some to attack your device, I'm going to put malware in through the market or a market. Write a malicious application, submit it to a market, whether it's Google's Play market or one of those third-party markets, or even maybe just post it on a website and tweet about it and see if people can download and install it on their devices. But the market malware is what we focused on specifically this summer. Myself and Sean Schulte did some research with Bouncer and actually wanted to see if we can get an application submitted through Bouncer and get it accepted. And it turned out we were able to. And basically, the way we did it is that we enabled that application to dynamically download JavaScript from a command and control server that we had. And so anytime that Bouncer actually went and scanned our application, we never served up that code to Bouncer. And then when it got submitted and accepted in the store and when we downloaded it on our devices, we would then serve up the code. So it actually wasn't very difficult, and it actually took a matter of minutes. And so as a developer, I actually went and signed up for a developer account. I went and did everything, followed the rules, actually used my real name and my real email address, and I found out later that wasn't a great idea. And basically went and signed up and created a Google checkout account and everything, just followed the rules and then submitted an application. And sure enough, it passed and showed up in the store. Eventually, we kept trying to up the ante a little bit of what we were doing when we were in Bouncer, and eventually we did get caught because we enabled everything, all the malicious functionality, just to see if they would catch it. But that being said, even if they didn't catch it, Google then still relies on user feedback. So it is sort of this cat and mouse game. If I'm able to build an app and submit it through their market and it gets out there, then all the users, I don't know who's going to find that there's malware, but the users who do detect this, probably security people, will report it to them and then they'll pull it out of the store. And then I just go and create a new account and then submits things again. So I guess moral of the story here is if you're going to do research, don't use your own personal email accounts. I actually found this out just the other day. I was trying to buy, I homebrew, I was trying to buy bottle caps online, and it turns out that Google Checkout uses a lot of metadata, and so I tried like 12 different email addresses, my name. I actually ended up having to have my wife buy me the bottle caps because I just couldn't do it. It just kept denying my transaction with 5 or 6 different credit cards and everything. It was pretty interesting. When you're talking about Android devices, the other piece that we look at are things like rootkits, right? So you have a kernel level piece of code running on your device, and then it has access to everything that the phone can do, right? So it can do things like snap photos if it wants to. It can record your conversations. It can do a whole slew of things. It also can hide itself from the device, from the kernel itself. Right, so that makes it very, very difficult. Even if you were to write a OS level, say, antivirus program, it would be very difficult for you to detect this problem as well. So we actually demonstrated this as well at DEF CON 18, and this is a number of years ago. So it was like 2 years ago that we demonstrated this and showed sort of the capabilities of a rootkit. The other vulnerability that sort of you may or may not be familiar with is that on Android itself, they allow you to do these things. Android SDK allows you to do things that you wouldn't necessarily think should be allowed. So the scenario you're able to pull off with this is something we coined sort of the focus stealing vulnerability, is that if you were to take your mobile device and you're looking at your screen, so you're typing along and you're in email, how annoying would it be that if you're in email and you're typing a message, that Facebook would just pop up in front of you? That would be pretty annoying. Or your e-commerce application would just sort of pop up and steal your focus. They would be extremely annoying, but you can do that with Android. It's still, it's a legitimate part of the SDK. You actually can do it. And you actually can create logic within an application that says, if person is running X application in the foreground, push another application into the foreground. And so if you think of that scenario, you could do things like credential stealing. And I'm going to demonstrate that. That's actually one of the demos I have. But we demonstrated this at DEF CON 19 to sort of show this vulnerability. We submitted this to Google, followed this full responsible disclosure process, submitted it to Google. They said, yeah, we think this is a problem. We're going to put it into our, sort of our Jira system, wherever they use to track bugs. And basically, they said they went away for 3 weeks. They then came back and said, hey, we want to have a phone call. Had a phone call with us. We said, oh, great. Did you guys test it out? We sent you the proof of concept. Did you, oh, yeah, we see the problem, but we can't fix it. We said, well, why can't you fix it? And they said, well, that's a feature of Android. There's legitimate applications using that functionality, and if we decide to kill it, it's going to break all those applications. So it still exists today. It actually, I have 2.2 running in an emulator, but it does work in Jelly Bean, the same vulnerability. So an end user could be sitting there using their online banking account, and all of a sudden a login screen could pop up that says log into your online banking account, and 99.9% of end users out there are going to type in their credentials and have those credentials shipped off to an attacker. So now I have some demos. So let me jump into some demos here. Let's sort of when you pray to the demo gods. So this first demo, let me start this up. And I'm going to give props out to Josh Grunswig, who's in the audience. So I've been giving these types of talks for a while, and one of the demos I thought was getting a little stale. And so I sort of challenged or asked Josh to see if he could come up with something more interesting than what I was showing. And so he actually went and we had a copy of FinSpy for Android. How many people are familiar with what FinSpy is? Oh, so a few of you. So FinSpy is a commercial, basically, spy application. You actually go, there's a legitimate company out there, or somewhat legitimate, you can go and you can pay them money and buy this malware and then go deploy it on people's devices. And you can do things like listen in on their microphone, sort of, you can record calls, you can get their SMS messages, you basically can do whatever you want on their device. If that got installed on your phone, you'd be in a lot of trouble, right? You'd be able to, whoever's commanding controlling this would be able to learn everything about you and watch what you're doing as you're doing it. So Josh went and we got a copy of this. It's running on this device, and so we don't have all the functionality sort of fully working. We're still digging into this. And if you want to learn more details on it, we just posted this morning. We just posted some to our blog, and so there's actually more granular detail than I'm even going to go through here. But one of the interesting things to show you is that there's a config directory in the APK. And inside that config directory, there's about 100 files within there. And when you look at all those files, there's 0 bytes in length. There's 0 bytes in size. There's basically, looks like there's nothing in them. And so Josh was digging around and actually found out that there's actually data in the headers of all those files. And if you take all those files and you recombine them, you actually can pull out a config. And so so I'm just going to run some of these commands here, and you can see this is like the hex dump of that config, and you can see some strings there. You can see derise there, and you can see maybe something that looks like a phone number and an IP address in that config. Well, that still doesn't really help us. And so so we go here. What we're going to do is we're going to extract that again and throw it to a file, and then we're going to go and Josh went in and wrote a tool to actually parse the config, so we actually can see what's going on. So this actually parses the config sort of in readable format, and so we can scroll back here and see, you can see things like mobile Trojan ID is derise, so whoever created this version of FinSpy actually put that in there. You can see there's a call phone number, there's other information in here as well, so we're all stored in here. So there's an IP address. This is sort of the target gateway. IP address stored in there as well. So this is pretty interesting. This was actually, the config is actually stored in these files. We thought was pretty interesting. We see a lot of malware. We didn't see something similar before, that they would actually go through that length to try to hide that config. And then the other thing to show is that when the malware starts up, and malware's running here, it actually runs as services on the Android device. When malware's running, when it first starts up, it actually goes and sends data out over SMS as well. So it has sort of two channels of command and control, or its communication. It uses SMS and over IP. And so when it sends things out over SMS, it sends these base64 encoded messages. So we actually have, obviously, show you what that looks like as well. This is what those messages look like. We thought it was pretty interesting that they actually spell Android wrong in their messaging. It's Android, or I don't know how you would pronounce that. But then you also have things like mobile country codes, mobile networks. Latitude and longitude, because we're running in an emulator, obviously isn't going to be populated. But some status codes and things like that that sort of map back to some of the other commands that the command and control may want to know, things like battery life and other information about the device. So then, so go back here and we'll show you. So then the other interesting thing is that we were trying to figure out, like, what are the messages it's sending? And we actually found out that it actually sends the messages using AES 256 encryption. So when it's talking to its command and control. Well, that's pretty interesting. Most of the botnet or the malware you see out there doesn't go through that level of sophistication. Maybe they use SSL or something like that. So they're actually, you know, very, very, I guess, concerned about people intercepting these messages. And the other piece to note is that there's two static strings that it uses in the encryption, and then it just concatenates the Trojan ID in order to basically initialize that encryption and use that key. So what we have here is a listener, and this has been running since I started up the demo here. You can see sort of a heartbeat. It actually, I think when I started up, it probably was at like 17. I think is where it starts in this snapshot. But every 30 seconds or so, it's been sending this heartbeat. And the other thing that's pretty interesting is, you use, because we know what the two static strings are, taking the device ID and concatenating those, we actually can decrypt the traffic as well. And so you can see here, this is basically the traffic. Here's it's using encrypted. Here's decrypted. Here's the string decrypted. And then here's actually what that means if you sort of translate it to the keyword values and things that are being sent back and forth between the command and control. You can see again, you see the mobile target ID is spelled wrong. You can see device ID. Obviously, this is an emulator, so it's not going to be there. Subscriber ID, mobile network code. I think that's T-Mobile is what that represents, because this is an emulator, and all the Android emulators say they're T-Mobile. And you can see status code. So very similar to what was being sent over SMS, but this is something, a heartbeat that is sent to the command and control. And then obviously the command and control will have the ability to send things back to control it. And we haven't gone that far yet. This is sort of a work in progress. In fact, I think this is brand new. We posted a blog post on this morning, and Josh handed the demo over to me just 2 days ago. So this is brand new stuff. The next thing I want to show you from a demo perspective, and this is sort of seeing that sort of sophistication of really mobile malware out there. It's basically like back orifice, right? So you have back orifice and things like that from the 90s. But it's being sold and being used by people who want to spy on people's devices. The other thing I want to show you is this focus stealing vulnerability. And so I described it to you, but I want to actually show you it as well and show you how dangerous it is. And sort of in my mind, if you think of someone using a mobile device, if I'm walking around on the street and I go, oh, I got a text message from somebody, I go and I open my device and I send a text message back, and they go, oh, I want to update my Twitter. I want my Twitter account and say, hey, I'm heading to this bar to try this new beer or whatever it may be. And I send, and I put my phone in my pocket, and then I pick it up and say, oh, I want to check Facebook. And I touch Facebook, and I look at it, and I go into Facebook and check to see what my friends are doing. I'm not sitting there with the screen in front of my face at all times. You're moving around, you're bringing it up, you're flipping it around, you're putting it in your pocket. And so display type vulnerabilities are things that are confusing, or things that are sort of pulling, it's almost like magic, pulling smoke and mirrors over an end user, are very, very dangerous, much more dangerous in the mobile world than they are in the desktop world. So basically what we have here in this demo is Sudoku. So we have Sudoku game. You go and you download this from the App Store. This version of Sudoku, I wouldn't recommend you put it on your phone. It actually has the malware embedded into it. And the malware has that logic that says if you're running app X from a list of apps that we have embedded in this malware, then do something. And so what we actually did is we took some popular applications, took the APKs, extracted the graphical elements in the APKs, and reassembled legitimate looking, actually pixel perfect login screens for popular applications. So now if you have this device on here, or if you have you're playing Sudoku, you go and you touch Facebook, you're actually going to see, and I'll show it to you, you're actually going to see the real Facebook screen come up, and then a split second later you'll see a fake Facebook screen pop in front, a login screen. And when the end user goes and types in their username and password, we're then sending it over HTTP off to a web server that we control that's running back here. So I'm going to show you that, and you can see, and I'll show it to you a few times. So you saw that animation, and that's this animation that sort of pops up every once in a while. But I'll show you it again. There's another animation, if you notice that, where it's slid in from the right. I can sort of show it to you again here. Now you notice, and so you think, well, how many users would enter their login and password in? Now, how many times have you updated an app on your phone that you used to have, maybe persistent, accounts in, that it forgets your accounts? I just updated Untapped on my phone the other day, and it now asks me for my username and password. So that's normal, right? So that people, and end users are like, oh, it forgot my password. They're going to type it in. So let me go and I'll type in my username here. And I'll type in my Facebook password. It's not really my Facebook password. Actually, I don't have a Facebook account. I did for a short period of time, but it's gone. So I'm going to enter that in, and now you'll see it. Obviously, it's being sent to the web server. Now, of course, in this demo, we're like an annoying piece of mail where it just keeps popping that screen up in front of you. But in the real world, maybe a user already would be logged into Facebook. They go and they click and they see their timeline and they see this login screen. And they go, oh, okay, I'm going to type in my username and password, and they hit submit. It gets sent off to the web server, and then it goes away. We don't ask for it again. We didn't put in any sort of sneaky logic in this app. It just continues to do the same thing. But we also have it built into things. Also can look for the Amazon as well. So you go and click on Amazon, it says, hey, give me your Amazon account. I can go and type in, I'm just actually going to type in garbage here. Type this in and sign in, and it should send it as well. And you saw that it went away and came back there. So that's an example of what I sort of see as really dangerous malware, because you're tricking the end user. And it's not as high tech and as interesting as something like FinSpy, but to me it's just as dangerous when it's used for its purpose. Most end users would not know this was going on. They wouldn't know which application they downloaded that had this problem. And then of course, everybody knows that mobile AV isn't all sort of up to snuff anyways. They would have no ability to detect this problem. So all they know is that all of their accounts, from Facebook to their online banking to every place else, all the accounts are being taken over, and they can't figure out why that's happening. So another demo I want to show you. Now this is the one that hopefully sort of prayed to the demo gods. It took a little while for this to get set up because there's apparently some jerk on the Wi-Fi network here that likes to deauth everybody. So we actually had to go and grab a MiFi to try to get everything working. But so what I have here, I'm going to show you. So this is what we submitted. Let me sort of make sure this heartbeat's still running. Yes, it is. Okay, cool. So what we have is, this is just a screen capture from this device that's sitting up here. This is an Android device. And basically, this is the application that we submitted to Google, and Google accepted and published in their store. We actually called it SMS Bloxor. It's an SMS blocker. So I was actually going to touch do it here. So it's an SMS blocker. As you can see, it looks like a generic application. You can go and you can enter it, you hit the plus, and you can enter a phone number. It actually legitimately works. And so we built this application, and this is the application that's dynamically calling back to a command and control server asking for new code. Very similar to your Facebook actually uses Facebook until they went to native applications, at least on iOS. I'm not sure what they do on Android today, but at least on Android at the time, they actually create an HTML5 and JavaScript wrapper basically, and they download all the content dynamically. So we're actually using that same thing that Facebook is doing to anybody how many people have Android devices that have Facebook installed? Well, we got a handful. So basically what we're doing here, Facebook, if they wanted to, can do to you as well. They could actually dynamically push down code that's unsigned onto your device and have it execute with the same permissions that the application has. So so let me show you here. So we built this command and control, and it sort of looks really nice and GUI friendly. But basically what you can see here is you'll see this heartbeat going. We have it set for every 5 seconds, and this is dynamic. I could change this to 5 hours if I wanted to, but for the demo purposes, I set it for 5 seconds. It's basically checking in. every 5 seconds and saying, hey, is there anything for me to do? Anything for me to do? If you click on here, you can see basically this is the information it's sending over now. It's sending over that it's a Google Samsung. It says the time it visited, and basically that's it. So let me go back home. And so now what we can do is we can turn on functionality. We can say, hey, I want to grab phone recon from that device. I go and turn that on. And if you watch, if we see an X in recon, if everything works, so we sort of pray to demo gods. Maybe not. Maybe not. So let's turn on something else here. I don't know, it's not checking in. The network connection die. Okay. So let's see. Let me launch the app real quick. See if I can get it to force check-in. Let's see. Of course, it dies right. It was, you guys saw that. It was chugging along and then decided to stop phoning home. Let me see something real quick. Well, that's working. Okay, let's turn on some. We'll just turn on all this stuff, and we'll see if we can get this phone to talk home. Let's see. Sorry, folks. This is what happens when you do live demos. Make sure I have an internet connection on this. Oh, is it talking again? Okay, cool. I don't know. Something must have been a blip in the network here. Okay, so cool. So now if you go back here, you can see nothing's changed on the screen, right? It's still showing nothing, and it's pulling down data from the device. And I went and sort of jumped the gun here to just try to get everything to work to save time. But I've enabled everything here. I have contacts, I have recon, I have phone records, and if I click now in here, I can see it pulled down all this data. So now I have all the contacts that are on the device. I have all the SMS records that are on the device. I have all the phone records that are on this device as well. And so you can, these are actually legitimate people where you're text messaging it when this phone had a SIM card in it. But basically you can see all the activity that's going on. And then we also can do things like pull down photos. So if I want to pull down sort of the newest photo, enable that. This is over sort of 3G, so it might take a little bit. But basically, we have the ability to pull down the newest photo, the oldest photo, and a random photo off the device. So if this thing, is it stuck again? You gotta be kidding me. This network must be just sort of, maybe it's congested or something. Let me launch it. Oh, cool, it pulled down the photo, okay. So let's see, hopefully it pulled down. No, here it is. Yeah, so it did pull down the photo. So that's a photo I just took a couple of minutes ago when I was in the exhibit hall there, on this phone. So you can see sort of it pulled down in. It actually has a phone number on it, but don't call that. It actually won't go. The SIM card's out of. It hasn't been topped up yet. So, but basically you can see sort of the power of these types of devices that this has. And so really, this is a piece of malware that's running on this device. And I'm often actually asked, when I've demonstrated this, people ask, well, does any AV scanners detect this activity? Is there any security software that you can install to detect activity? You can see here, let's see, let this refresh. Maybe not. Live, oh, error. Let's see what's going on. Hold on a second, sorry. Let's see if I can get this plugged back in. Rejected, I've been rejected. Let me pull this out again. Well, I can hold it up and show you. Rejected. Hold on, folks. Let's run this again and see. It's rejected again. Oh well. So let me so you can see Lookout is running on here. These people in the front row can see, and Lookout says everything is okay on the device itself. So there is malware running on there, and it's being accepted, or it's scanning it as everything being okay. So those are the demos I have, and then the other things. So we talked about mobile spy kit, focus stealing malware, and info stealing botnet. And one of the functionality that we also can do, which isn't going to be really helpful with a screen like that, we actually have the capabilities of going and this hijack piece here. I actually can type a URL in there, and the phone sitting right here would actually just go to a URL. The browser doesn't have to be open. A browser opens up and just visits a URL, any URL I specify. And then the botnet piece here, which I'm not going to run because that'll saturate this 3G pretty quickly. We actually put the capabilities in there that I can specify a website and have this device send a lot of traffic, just continuously send traffic to that website. Now, a device it's by itself, one device infected with this, not a big deal, right? So the traffic should be able to fend that off. But if you had 100 or 1,000 or 100,000 devices running this, it could be a problem. So, so let's go back to the, actually, yeah. See if I can get this to show you. Rejected. I have no idea why it's doing that, but so let's go back to the presentation here. So let's talk a little bit about the future, and so things that sort of prediction type things. And some of these things may be a little bit out there, but some of the things are completely realistic. In fact, one of the future pipe predictions I put in here before I started talking with Josh, and we pulled the FinSpy demo into the presentation as well. So. So the future. So we know attackers are retooling their skills, right? So they used to target traditional PCs. They used to target those types of devices. They're retooling the skills to target mobile. There's FinSpy before it was on the mobile platform. It was targeting Windows. They've now moved some of the development efforts towards mobile because that is interesting. And in fact, data on PCs, I would sort of venture to guess, is becoming more stale than on mobile devices. You may have your PC and you may use Word. You may use maybe an email client, you use a web browser, but on your mobile device you have a lot of other information, a lot of access to a lot more information just from that mobile device itself. And then also, devices are becoming more personal. So, always on devices sitting in my pocket, that's close to my person, right? Like if someone was to get access to the camera and turn it on, they'd be seeing my face right now as I'm talking. But also wearable computing. We've been talking about that for what, 2 decades. Google has a whole team working on that, right? The Google Glass project, where you'd put glasses on, right, and you'd be able to see things sort of in your augmented reality and possibly interact with that in certain ways. So things are becoming more personal, and then market penetration and user-granted visibility sort of clash. And what I mean by that is that the more people you have in the world using mobile devices, the dumber the devices have to be from an interface standpoint, right? So you have to dumb down the interfaces so that someone who maybe has never touched a computer before can go to the Apple Store and buy a device and start using it. And they certainly don't want to see a command line button someplace where they can get, type in Unix commands. They certainly don't want to see all these sort of pop-up windows coming up complaining about security issues. They just want to make a phone call and they want to be able to buy something online. And so those things sort of clash, and also manufacturers don't want users to break things. So a lot of the control that you have on these platforms out of the box without rooting or jailbreaking them are very, very limited. And so so if something does get on those devices, you have very limited visibility into what's going on. So here's some ideas, and so the future. So this concept of a sleeper cell app. Now, we see a lot of these applications being written out, the malware out there. If you've seen some mobile malware, sometimes it's just really garbage, right? The interfaces look really bad. Sometimes the spelling is horrible, as we even saw in FinSpy. It's a commercial product and they spelled Android wrong. So, but if you really wanted to, you can find a legitimate software developer, someone who writes really great, popular games, and say, here's a lot of money. We're a government or we're an organized crime group. Here's a lot of money. Create me a game that is going to become popular. Sure, you pay, and also, and there's the and, I'm going to pay you extra. You put malicious functionality into that application, but give me command and control of that. And I'm not going to turn it on until it becomes popular. So if you imagine, say this happened in the Angry Birds world, right? Say the Angry Birds developer, they're really evil, and they said, we're going to get Angry Birds on everybody's phone, and then one day we're going to flip a switch and it's going to start doing something really, really evil. That would be a real big problem, because how many people in this room have Angry Birds on their mobile device? Wow, like half of you. So that would be, if half the world's population with mobile devices is Angry Birds, that becomes a problem. And so then if you think about sort of an attack that's targeting from hundreds of thousands of devices, that's dynamically being turned on and off, imagine the investigation. Imagine like you're the company and you're like, our website is being attacked. It's getting DDoS attacked from 100,000 devices, and you track it back and it's like on the Verizon network, on the AT&T network, and you're like, well, how do we stop this? And then you call up those networks and they say, well, we don't know. There's these mobile devices and now it's gone, right? It's stopped. And then 3 weeks later, it starts up again, and it's coming from different IP addresses, because obviously people are roaming around the world. And then even if you were to get access to, say, the carriers, and you're able to get Apple or Android to work with you and try to figure out, here's these devices, what application is on those devices, they may have hundreds of applications on those devices, and many of those may be in common. And so it becomes a very, very almost fruitless effort to try to detect this and actually stop it if this was to happen. The other sort of future piece, and this is interesting, I sort of wrote up the slide, and then Josh came to me and said, hey, we have Spy Eye on Android. This is sort of, it's ultimate spyware, right, that gets deployed on people's devices, able to read email, calendar, SMS, and photos, identify locations of devices, recorded audio, listen, or even video from the device. In fact, if you have a piece of malware on a device, you can have a very, very targeted, coordinated attack against an individual. Say you have an individual like a CEO of a company, and you have a piece of malware, spyware on their device, you can read their calendar and know exactly where they're going. They're going to have a meeting maybe with another CEO of a company to talk about a merger. You see that on their calendar. You now have access to their microphone and their video camera and the photos, and you can turn that on and you can download all that information. So you know, and you say, well, I'm going to turn on the microphone at 2 p.m. on Friday because I know they're sitting in a meeting with this other CEO, and you record that conversation. And so these are things that we don't really see that much, obviously, in the wild. You see FinSpy has that capability, but I would say in the next several years, you're going to hear more and more about this. This is an avenue where this world is going. And then this is where things get sort of more like sort of out there, sort of bleeding edge, when I sort of talk about personal connections. So you can possibly cause environmental issues around devices, right? So I actually overheat a battery on someone's device to start a fire. Now, if you have a piece of malware, you know where they're located, they're in their workplace, or they're in their car, or they're in their home, and you overheat their battery and their phone starts on fire, that's causing environmental damage, sort of personal to digital connections. And so that knowing the attackers could benefit. And actually, when I was giving my talk at DEF CON this year, someone's phone did start on fire in the audience. So I don't know if it was malware or what, but they had an Android phone. It literally started on fire. They threw it on the carpeting and like burst into flames. That's actually what gave me this idea. So if you can actually cause that, even a room of people, there's a conference going on. You say, hey, here's an application, download it, and now you have malware in there, and you cause everybody in the audience's phones to start on fire. That's it's almost like a form of terrorism, right, via mobile devices. The other piece is you can sort of evoke physical harm. Obviously, something starting on fire in our pocket is causing physical harm. But imagine you could play things like infratones or other sounds sort of in the background while they're listening to music that causes nausea or dizziness on someone's device. And so that could cause if people listening to iTunes and all of a sudden someone's just vomiting, right? Every time they listen to use iTunes, they would be really confused. They go to the doctor and say, I'm sick, and the doctor can't figure it out, and they go back home and they put on their headphones and they throw up again, right? So so that would cause sort of all kinds of problems in society if that was happening. And then the sort of other thing, this is like bleeding edge, 10 years, maybe 20 years, as we're getting these wearable computing devices, you go and you put on your Google glasses, right? And it has sensors, obviously, probably going to be maybe have blink sensors and things like that. You can record, possibly you can retool the sensors, record brain waves. Maybe there's some technology in it that could be used as sort of an EEG, single channel EEG sensor. Brain waves, body heat, maybe even sense emotions, and meld that into the malware you have going on that device. It can become very powerful. So that's just some future ideas and things. So I think I have like 3 minutes left, right? So conclusions. So mobile, in my mind, is really still in its infancy. We're like right at the beginning of sort of society using mobile devices, but also from an attacker's perspective, we're at the beginning as well. It would be really silly to think that the attacker is going to stop with building a tool like Spy Eye or something like that. It's going to evolve, and it's going to get more powerful and have more capabilities as these devices get more capabilities. And then also the mobile platforms are not doing a great job of letting end users, general end users, or even advanced end users, ensure that their devices are in fact secure. And so that's a big problem. So the manufacturers have to do something as well. And then, these capabilities of these devices sort of bridge what I sort of call the physical and digital barrier. Things are going to get very interesting as that barrier sort of gets blended together. And so, bottom line, mobile can enable greatness for societies, but awareness of these risks and these threats are very important as well. So with that, some resources that you can visit. Our blog, like I mentioned, Josh just wrote a blog post this morning on FinSpy, so you can check that out. And then follow us on Twitter as well. So with that, thank you. I think we have the next guy coming up in about a minute. I'm going to be, after this, if anybody wants to chat,